Alrighty, hello everybody. We are back at the kitchen table with the plants, thinking about lesson number 23. Even though lesson number 23 is happening before our second midterm, it is technically our first lesson of Unit 3, and so this material is not on midterm number 2. It's just because we got to keep going forward with this content. So lesson 23, the task card is up here on my laptop. You'll see that the very first task is to fill a bowl with 50 pairs of paper clips. Now, I don't know how many of you have 100 paper clips lying around. I personally have 12,000 of them in my office right now, but most of them are going to go unused because we can't do this activity in person. But I went ahead and took 100 of them and paired them up. Oh, this one's kind of tangled, but they're linked together in 50 pairs, and they're here in the bowl. So I understand that not very many people are going to be able to follow along with this in person if you just don't have these supplies lying around. But hopefully watching this video will give you some idea of what that experience would have been like. So I've filled my bowls with 50 pairs of paper clips. Step number 2 is to grab a paper clip out of the bowl. If it is attached to another one, I'm supposed to unlink those 2 paper clips and put them both back in the bowl. If that paper clip is not attached to another paper clip, I put it back in the bowl. So that looks like this, in case you couldn't imagine. I mix it up a little bit, I reach in, I grab, look, they are paired up. And so, this is hard to do with one hand, but I did it because I'm amazing. Here are 2 separate paper clips, I put them back in the bowl. And so you do this 99 times. Whew. And record the results on the irreversible table on your note sheet after every 10 tries. So I did that earlier, just kept reaching in and unlinking them if they were attached, and linking and leaving them if they were unattached to one another. And here is what my data looked like. It's this table here on the left. So I started out with 0 numbers of A. So in this case, A2 is 2 paper clips linked together, and A plus A is the single unlinked paper clips. So initially I didn't have any one single unlinked in the mixture. Sorry, that's depicted here. I didn't make any because I hadn't tried any yet. And then I had 50 of those pairs. And then after 10 tries, because every single one of those 10 tries I managed to grab 2 linked paper clips and unlink them, I did that 10 times, so I got 20 single A paper clips in those 10 tries. That 20 plus 0 gives me 20 single paper clips overall, and that subtracted 10 from my number of paired paper clips, my A2. And so after making 20A, I now have 20A and 40A sub 2 in my mixture. Notice that these numbers, this one times 2 plus this one, should always add up to 100. So 40 times 2 is 80, plus 20, that gives me 100. That makes sense because there are 100 paper clips in there. Just some of them are linked together and some of them are not. Then I went ahead and did it 10 more times. That time, I didn't always manage to grab a pair of paper clips every time. Sometimes I would reach in and I just happened to grab a single paper clip that wasn't attached to anybody. That didn't happen this time, but imagine that's what had happened. So it turns out only 7 of those 10 times did I actually grab linked paper clips. And so that was only 7 of the 10 times that I was able to make A2 into A plus A, and that gave me 14 single paper clips in those 10 tries. Adding that 14 to the 20 I already have, I now have 34 single A paper clips in the bowl, and those 7 that became 14 A's got subtracted from the 40 A sub 2 that I had, and now I only have 33 of those. And we can check again, 33 times 2 is 66, plus 34, we still have 100 overall. So I did that a whole bunch of times, y'all. It was a wild and crazy morning for me. So if you don't have the paper clips at home to do this yourself, you can just copy down this data and use this as your data for the rest of this activity. So you can go ahead and pause the video and write those numbers down if you need to. The next step on the task card is to graph your results on the back of the note sheet. So there are two sets of axes on the back of the note sheet. One is for this table and one is for this other table we'll fill in just a second. So you can go ahead and pause the video and fill in the graphs of how the total number of A is changing after 10, 20, 30, 40, 50 tries, and how the total number of A sub 2 is changing after 10, 20, 30, 40, 50 times. Just make a little graph, easier to process than a table. Okay, so assuming you've made your graph now, the next step is number 5, which is to repeat steps 1 through 4, but with a second group member also reaching in with 2 hands to link single paper clips together. Okay, so what this second repetition is modeling is what we call a reversible reaction. These word pop beads, that refers to a different toy that you can use to do this model, but you can think of them as paper clips. So over here we just had an arrow pointing from left to right saying we can only grab linked paper clips and make single paper clips. Here we have an arrow pointing both directions. So there's one group member who can grab the linked paper clips and unlink them. And then there's another group member that can reach in with 2 hands, and if both of those hands grab a single paper clip, they link them together. So we can actually both do and undo this linking and unlinking if we want. So I did that part already as well, reaching in with 1 hand and 2 hands, seeing what happens. And this is the data that I got for that. So after 10 tries, I had unlinked all 10 of the ones I grabbed with 1 hand to make 20 single A paper clips. But the grabs with 2 hands never came up with a single paper clip in both hands. So I never made A sub 2 in those first 10 tries. So I made 20 total A, that's the total in the mixture so far. That resulted in a decrease of 10 A sub 2. And notice these still add up to 100 if you multiply this one by 2 and then add it to this one. So I kept doing that, many trials all the way down here. I do want to demonstrate to you just how I calculate the numbers that go in these 2 columns. So after however many tries this was, I guess 70, I look at the fact that I, at the beginning of these 10 tries, had 62 single paper clips in the mixture, and I say, oh look, I made 4 more, so that's 66, but 10 of them, 5 times 2, went into making A sub 2. So if I made 4, but I lost 10, then that's 56 overall. Right? I lost 10, that takes me down to 52, but then you add 4 back in, and that's 56 total single paper clips in the mixture right now. I can think about the number of A sub 2 in the mixture as well by thinking about, okay, well, I lost 2 of them, 4 divided by 2, making A, but I gained 5 of them. So if I lost 2, that's down to 17, but plus 5, that's back up to 22. That's what goes right there. So based on that logic, I'm going to challenge you to fill in these last 4 boxes here and try to ignore the fact that you can see my ghost writing. I'm just going to cover it up. Haha. And see if you can calculate those numbers. Give yourself a few minutes. You can pause the video if you need more time. But yeah, you're exactly right. So if you had 56 and you gained 6, but you lost 4, then you really only gained 2. So that should be 58 single paper clips in the mixture after that step. If you had 22 A sub 2 species and you lost 3, that's down to 19, but you gained 2 more, you're back up to 21. And then for our final step, we have 58 A in the mixture. We made 10, but we lost 8, so we really only gained 2. That brings us up to 60. Versus we have 21 A sub 2 in the mixture. We lost 5, taking us down to 16, but then we gained 4, bringing us up to 20. And we can double check one last time. 20 times 2 is 40, plus 60 is 100. Beautiful, beautiful. Okay, so this is the sample data that you can use to then graph this second table on the back side of the note sheet. So I'll give you a few minutes to do that. Go ahead and pause the video and make your graphs. Okay, we're back. Here is what my graphs look like. So we start with 50 pairs of A sub 2, and those gradually decrease over time until we have only 5 pairs left in the case of the irreversible reaction, the one where nobody was putting them back together. The single paper clips A start at 0 but ascend all the way up to 90 by the time we're done doing this model. This is a little different from what happens in the case of the reversible reaction, which A sub 2 still starts at 50 and A still starts at 0, but we find that A sub 2 kind of levels off. There's a little bit of wiggle, but that's probably just the nature of experimental science, right? Nothing's perfect, but it kind of levels off around 20, right? 20 of these A sub 2 paperclip pairs. And then the single A paper clips level off around 60. So there's a key difference where this A is kind of ascending, maybe it's going to level off around 100. This A sub 2 is going to level off around 0 versus these more intermediate values in the case of the reversible reaction. So let's go ahead and move on to step 6 on our task card here, which asks us to compare the results of the irreversible and reversible reactions. What happens to the rate of the forward versus the reverse reaction? Okay, so initially with our irreversible reaction, the rate of the reverse reaction is, what do you think? For the irreversible reaction, what is the rate of the reverse reaction? Yeah, I agree, it's 0. The reverse reaction never happens. As opposed to with our reversible reaction, we definitely have some non-zero reverse reaction happening. And what do you notice as we get to kind of a level place in terms of the number of A and the number of A sub 2? Yeah, I mean, it wobbles a little bit, but if we think about looking at the number of A sub 2 that gets made, it's usually about half, right? There are some instances at least where it's about half. 3 is half of 2, 2 is a little less than half of 6, 4 is a little less than half of 10. And so if you're getting half as many A sub 2 as you're getting A, this must mean what about the rate of the forward reaction compared to the rate of the reverse reaction? Would you put an equal sign, a greater than sign, or a less than sign here? Yeah, I agree that eventually these things are about equal to each other. And the reason why that makes sense is because when you go forward once, you get twice as many A as when you get go backwards once to get an A sub 2. So even though this number is twice as big as this number, that's more a product of the stoichiometry here than it is of the rates being different. The rate of the forward reaction is the rate of the reverse reaction eventually for the reversible reaction. Eventually. It didn't start out that way, right? At first, we didn't have any A to make A sub 2 out of. So at first, we were definitely going mostly forward. But eventually it leveled out to the point where the rate of the forward reaction was equal to the rate of the reverse reaction. So the second question that we're being asked here is, why doesn't the reversible reaction ever go to completion? And for this question, I want to direct you back to our graphs. So first of all, what do you think might be meant by the phrase go to completion here? Yeah, so I would say that going to completion is more what we see with the irreversible reaction, where A sub 2 eventually gets used up all of the way. It goes to 0, and A is all we have left. So goes to completion means you have no reactants left. So do we have that situation in the case of the reversible reaction? No, that's right. At least if we expect this pattern to hold, A sub 2 doesn't go all the way down to 0. It just holds out at 20. A doesn't go all the way up to 100. It just kind of stabilizes out at 60. And so the reversible reaction does not go to completion. Why not? Because there was the linker undoing the work of the unlinker. Right? It got to a point where every time you unlinked a paperclip, somebody else reached in and linked them back together. And so you don't really make any progress after a certain point. So the linker undoing the work of the unlinker keeps the reversible reaction from going to completion. Once again, you're welcome to write whatever you want to write down on these note sheets. They are for you, they are not an assignment. And so if there's something I'm saying or something that clicks in your brain that's not exactly what's written down here, please write that down instead. These notes are for you, not for me to see a perfect representation of what my terrible handwriting said. Okay, so we have worked our way to the final step of this task card, which says to predict, test, and explain what will happen if the unlinker has to count to 3 before unlinking. Okay, so I know y'all didn't get to see me actually do this, but it did involve another human being and us jamming our hands in here at the exact same time. We were kind of competing for the paper clips. So what this last step is suggesting is rather than everybody jamming their hands in at once and trying to get these 100 trials done as quickly as possible, what if the unlinker is slowed down a little bit? And even if they manage to grab a linked pair of 2 paper clips, they have to wait before they can actually unlink them. So if we can consult our reaction scheme here, we see that unlinking is the forward reaction and linking is the backward reaction. So essentially what we're saying here is we're slowing the forward reaction just because of the way that we have defined the reaction here. Unlinking is in the forward left to right direction. Okay, so this is all you. You got to make a prediction about what you think will happen. Let's say that we're going to start from right here. They're already leveled out at 20 A sub 2 and 60 single A paper clips. So let's say we're just going to start with the bowl right there and then inflict our slowed down forward reaction. So take a few minutes, pause the video, and make a prediction about what you will think will happen to the graphs of these 2 species. Okay, we're back. So I went ahead and made my own prediction, not necessarily worrying about whether it's right or not, right? Sometimes our predictions in science are incorrect, and that's fine. But my prediction was that because the forward reaction, which makes A plus A, is slowed down, I was thinking we will just end up with only A sub 2 left. because I figured while the unlinker is doing all that waiting, the linker is going to take over and be able to make a whole bunch of A sub 2. So that was my prediction, but then I went ahead and tested. Okay, so my phone ran out of space, but I managed to fix the problem, and we're back. As I was saying, I made this prediction thinking that slowing the forward reaction, which makes A plus A, would mean that we end up with only A sub 2 left. But then I actually tested it out. So I started with a mixture that was, let's check the end of that graph. It was 60A and 20A sub 2. And then I actually did this test where I did the 10 groups of 10 trials, but the unlinker had to count to 3 before unlinking. And my prediction actually wasn't correct. Rather than ending up with only A2, I did end up with a little bit more A2, but I did still have 50A hanging around. And the explanation for this, I think there are a variety of ways to think about this, but I can kind of give you a qualitative sense of what went down as I actually had my hand in the bowl, which was that yes, initially the unlinker was doing a really bad job, and so we were doing a lot of linking to make A sub 2, and so that's how we got up to 25 or maybe even a little higher. But then after a little while, there was so much A sub 2 in the bowl that even though the linker had the competitive edge, they couldn't find 2 single paper clips in this bowl to put together. So eventually the dominance of A sub 2 actually ended up slowing down the backwards reaction as well. And so yes, the forward reaction slowed down, but so did the backward reaction. So yes, the forward reaction was slowed, thus decreasing the amount of A, single paper clips that we had formed, but that lack of A then slowed down the reverse reaction also. So they ended up both slowing down. Eventually they both became equal to each other, like we experienced initially. And so we established a new equilibrium. It wasn't in exactly the same position as it was before, but it was kind of a stable state in the end as well. So sorry this was split up into 2 videos, and sorry I'm guessing not very many of you had the opportunity to actually do this one, but if you're really bored sitting inside quarantining yourselves, maybe you can get your hands on 100 paper clips. Look in between the couch cushions, look under the bed. Maybe you can get your hands on at least 20 and do a mini version of this experiment. But in general, the key ideas are the eventual equaling out of the rates of the forward and backward reaction, leading to a lack of change over time in the amounts of A and A sub 2. Okay, y'all, that's it for me today on lesson 23. Go ahead and check out the video lecture on B courses to get the rest of the concepts, and then I will see you again on Wednesday.